Alright, let's say you drew two straight lines, 3x plus y equals to 3, and negative 4x minus y equals to 4. And let's say we wanted to find the intersection point between these two lines. Normally when you want to find the x-intercept or the y-intercept of a line, you would just solve that equation by itself. In this case, we are trying to find the intercept between two lines. So you would have to solve these two equations together. Or in other words, you are solving two equations simultaneously. There are two ways to go about doing this. You can use substitution or elimination. Since elimination is generally faster and easier to learn, I will explain how this technique works using two examples today on MathBase. So in our first example, we have 3x plus y equals to 3 and negative 4x minus y equals to 4. We will call the first equation number 1 and the second equation number 2. When it comes to elimination, we're looking for two matching variables and terms so that they can eliminate each other. At the moment, nothing matches here, but the easiest thing to match is the smallest term, which is positive y from the first equation and negative y from the second equation. Generally, I prefer to work with positives, so what I'm going to do is take the second equation and times it by negative 1. This gives me 4x plus y equals negative 4. Now write the first equation under this. And what we're going to do is minus off this equation from the one we just calculated. And they're going to minus term for term according to which term is under which one here. So it's very important that you align them according to their variable or if they're a constant. So working from left to right, 4x will minus 3x, giving us 1x. Both the positive y's will minus each other to cancel, and so that will just be plus 0. On the right-hand side of the equation, negative 4 will minus 3 to give us negative 7. So once you clean that up, we will see that x equals negative 7. So we have found the x value of our intersection point. Now we just need to find the y value. You can do so by using equation number 1 or equation number 2. Equation number 1 looks a bit easier to work with since it has smaller numbers and it's all positive. So let's substitute negative 7 for x into that equation. 3 times negative 7 is negative 21. Add 21 to both sides and we will find that y equals 24. And so the intersection point between both our lines is negative 7, 24. And that's our answer. So in this example, we only needed to change one thing from one of the equations in order for them to match so that they can eliminate. The next example has an extra degree of difficulty to it, so let's see what this looks like and how we deal with it. Alright, so our first equation is negative 2x plus y equals 4, and our second equation is 3x minus 3y equals 6. As usual, make sure you number them 1 and 2, because this will be easy to navigate when you want to refer back to it later. Upon inspection, we can see that the second equation has a factor of 3 in it across all terms. So take that and divide by 3 to every term, giving us x minus y equals 2. Let's call this equation number 3. We wanted to do this because it's going to be much easier to solve simultaneous equations when all the equations are in their simplest or most reduced form. Now keep in mind that since we changed equation number 2 into equation number 3, we can't use these two together to solve anything. We'll have to use equation number 1 with equation number 3. So if I just block out equation number 2 for a second, and we compare equation number 1 and number 3 together, we can see that the simplest thing to change would be the negative on the y term in equation number 3. So take equation number 3, times it by negative 1, and we will have negative x plus y equals negative 2. The alternative would be to take equation number 3 and times negative 2 so that the x terms would match. So keep in mind that you don't have to match the y terms. You can always match the x terms instead and eliminate that. It really just depends on which one's easier to work with. Now write equation number 1 below that and minus it off. Negative x minus negative 2x is the same as saying negative x plus 2x, which equals to positive x. The positive y terms cancel each other, so that's plus 0. And then on the right-hand side of the equation, negative 2 will minus 4 to give you negative 6. When you simplify this, we get x equals negative 6. And that's our x value for the intersection point. Take that value and substitute it into equation number 3, seeing that that is the simplest one to work with. So we have negative 6 minus y equals 2. Add 6 to both sides, and we have negative y equals 8. Times negative 1 to both sides, and we have y equals negative 8. And so our intersection point is negative 6, negative 8. And that is the end of the question. So in both examples, not only did we look at how to use elimination, we also learned that when you solve two equations together, you are effectively finding the intersection point between two lines. But how would we solve this if both lines were parallel to each other and never crossing? Or what about two lines that are overlapping each other? Or in other words, they are coincident lines. In order to find solutions for these scenarios, you would need to compare their slope values and their y-intercepts. So I would like to go over this advanced concept in the next video. But this is all the time I have for today, so thanks so much for watching, guys. I hope you enjoyed this. Please like the video if you found this helpful. Comment down below to let me know what you think about this technique, and if you would like me to teach substitution. If you haven't joined the channel yet, please click the subscribe button down below and ring the bell so that you can get notified for when the next video comes out. So thanks again for watching, guys. Have a good one, and I'll see you next time.